So let's look at, we are changing. Look at, switch to the goat problems today. Okay. There's really not a whole lot of difference. We're going to add one more step to what we've been doing, which last week I felt like we were kind of, we had it, we were on it, right? But let's review because we've had that whole weekend in there. So our goal last week was just to be able to solve a trigonometric equation. Okay. Now we're going to solve something called a multiple angle trigonometric equation. Okay. So as a review of what we did last week, okay, we started with really simple ones where we just had like sine, cosine, tangent, and they gave us the exact value we had to find the angle. We used our unit circle to do that. Most of us were like right there. Okay, we were getting it. Okay, because we'd done that before. All right, then we got to this part where Mrs. Ballard said, hey, let's solve that one from algebra 1 or pre-algebra. You were able to do that, and then we just added some trig to it. Okay, so we did was we added some algebraic steps in there in order to get us down to like sine of x equals 1/2, and then we reverse our unit circle and find the radian measure. Okay, and we're only going to worry about radians. We're not worried about degrees. Okay, we're making that transition right now, or we're just working in radians. Okay, all right. Then so today the big difference is on Friday. Or Thursday and Friday, we did not have anything inside there with the x, right? It was just sine x or sine theta or whatever it was, or tangent theta. But look at example 17 here. Do you see how we have something inside there with the x? So now I have more than just an x. So that adds an extra step to things, okay? We're still going to start exactly the way we did. We're going to solve this just like we did last Friday, and I'll tell you when we're going to do that extra little piece, okay, how we're going to deal with that extra little piece, okay? So let's just isolate the cosine 3x. What do I need to do first? Add 1. Perfect. So we're going to do 2 cosine of 3x equals 1. Okay. All right. I now need to get that 2 to the other side. How do I get the 2 to the other side? Divide. Good. Equals 1/2. Okay. So in our previous problems, when we were solving this, we would say, hey, x equals. Okay, so here's where we're going to make a change. Okay. It's not going to be x equals anymore, or just x equals, because that was coming from inside of here. It's going to be whatever's inside of there equals. So it's going to be 3x equals. And I'm going to do it a couple of times because I need to solve for the x. Okay. So that'll make sense here in just a second. Okay. So let's go to unit circle. Cosine the x values or the y values? X values. So I'm going to go find everywhere where my x value is positive 1/2. So I'm looking around my unit circle. It looks like the first time is at pi over 3. So I'm going to write that down. Pi over 3. And I'm still looking for a positive 1/2 in the x spot. It looks like my next one is at 5 pi over 3. Okay. All right. So now here comes the last little bit of this. And this is the new part for today. Okay. We said, hey, you got to set it equal to whatever's on the inside of that trigonometry. Okay. Now I need to isolate the x. All right. Right now, these are multiply. How do I undo multiply? Divide, or multiply by the what? Reciprocal. So I'm going to multiply by the reciprocal on these. Okay. So that gives me, so the x's over, or the 3's would cancel, right? I get x equals and go across the top. That's a multiplication symbol, not a like, it looked like a weird pi or something. So across the top, I would get pi. What's 3 times 3? 9. Okay. And then on this other one, again, the 3's would cancel. I get 5 pi across the top, 9 on the bottom. Okay. So it added one extra little layer. Okay. I think it was Friday we added, it was sometimes, yeah. Okay, so Friday we got some of those ones that had like 4 answers instead of 2. I don't know that we're going to see much of that today. Okay. All right, here's what I want you to do. I want you to try 18. See if you can do it before I add sides, or what is it, secant and tangent and cotangent. See if you can do it just with the sign. Okay. I know the sign looks like it's on the wrong side. Don't worry about it. Just leave it where it's at. Okay, and see what you can do to solve for it. Same steps as we did in 17. Okay, so everybody's trying it right now. Start by isolating sine, just like we did last week. Okay, let's see where we're at. Okay, so again, I've got to try to get sine by itself. So what's the first thing I'm going to do with this 1 right here? Add it. Okay, so what's -1 plus +1? Oh, 0. Okay, so is sine the x value or the y value? The y value. Okay, so I need to figure out where the y value is going to be 0 every single time. And I'm going to set that equal to 2 theta. Okay. All right, so y value equal to 0. What's the first place you found it at? Okay, so who wins, 0 or 2 pi? 0. So I got to say it's equal to 0. Okay. And then where's another place you found it at? Also at pi. Okay. And then remember we talked about last week that when I have the parentheses there, the 2 pi is not included. Okay. So you kind of ignore the 2 pi part. Okay. 0 wins. All right, I got to get theta by itself. So how do I move these 2's to the other side? Divide or multiply by 1/2. Both of those things work. Okay, so what's 0 divided by 2? 0. So I know one of my radian measures is 0. And then I'm going to take it, I'm going to divide the 2 over, or pi divided by 2 is just going to be pi over 2. Okay? Any questions so far? Okay. If we've taken this really slow to make sure we've got this, okay? Because we do need this when we go on to that next level. We'll see it again next year, okay? All right. In fact, this is I told you last week, this is like our first set of weekly skills checks as I make sure we can do this stuff. We didn't forget it over the summer, okay? All right, let's take a look at 19. So now we're moving into the world of secant and cosecant, which we know they're kind of like sine and cosine. If we had to pick on ones that we wanted that weren't sine and cosine, these are the ones we would probably ask for. Okay. All right. What am I going to do with that 3? Subtract it. So secant of 4x, what's 5 minus 3? 2. Okay. So now I'm going to go looking for reciprocals, right? What's the reciprocal of secant? Cosine of 4x, and I'm going to flip this. Technically, there's a 1 in the denominator, so I'm looking at 1/2. Okay. So I'm going to look for where the x value is 1/2. That's correct. And I'm going to set 4x equal to that. So I'm going everywhere around the unit circle, and I'm looking for that x value of 1/2. Where does it happen? Pi over 3, I like. What else? Where else? Also 5 pi over 3. Excellent. Okay, what do I need to do now? Okay, so divide by 4 or multiply by what? 1/4. Now, I sometimes take a shortcut because I know the 4 is going to go away on the left side. So sometimes I just write this. Multiply by 1/4 if I need to see it in my head. Okay. All right, so that would mean that x equals pi over 12 and x equals 5 pi over 12. Okay, here's what I want you to do next, okay? Any questions on 19 before we go to 20? All right, just isolate cosecant for me. Let's try that part and make sure we've got that part down before we do any weird flipping or anything. So just take like 45 seconds, isolate cosecant. Don't go all the way, just isolate cosecant. Okay, let's see what we got. So what am I going to move first on this one? 3. How do I move the 3? Subtract it. So what's 1 minus 3? -2. Good. And then how do I move the -2 that's in front? Divide. Good. So it's -2 divided by -2. 1. Good. Okay, and then now we're going to do reciprocal. So what's cosecant the reciprocal of? Sine. And to do the reciprocal, don't I just flip the 1, which is still going to be 1? Okay, you try it from there. Okay, see if you can finish it. So find everywhere where the sine is 1. Okay, set -3 theta equal to it. Okay, what radian measures did you write down for sine equal to 1? Pi over 2, I like. Anywhere else? No, because it's equal to -1. Okay, so I don't even need that, do I? All right, how do I move the -3? Divide or multiply by what? Reciprocal, which is going to be? Yeah, does it matter where my negative goes? No, I could put it anywhere I want. Okay, so I go across the top. I'm going to go pi. I'm going to move the negative out front. What's 2 times 3? 6. One thing I want you to be aware of, okay? So I may use the worksheet generator thing, and I made a worksheet, right? In that worksheet generator, for some reason, and I don't understand who programmed this, okay? They don't put parentheses in front of their things there. Okay, so in front of their, so it might look like cosecant of -3 theta. Just write your own parentheses in there, okay? So just in case there's no parentheses, assume they're there, okay? All right, let's look at 21. On 21, there's a typo, okay? It says like plus or something, right? Let me look, because I think I fixed the typo because Miss Hamby was trying to do the notes. She's like, something's wrong with that problem. It was intended to be a times, not a plus. So get rid of the plus, okay? All right, look at this, how quick we have gone today. We've only got 2 examples left, okay? I know we're really sad about that. All right, I've got to get the tangent by itself. Okay, so what am I going to move first? There's lots of 3. So am I going to move the multiply 3 or the plus 3? The plus 3 goes first, right? Think about what we're doing. When we're doing this, please excuse my dear Aunt Sally. When I'm trying to reverse this, I always start with this end first, right? Instead of going parentheses first, I do addition subtraction first. So I go backwards, okay? All right. So I've got 3 tangent of x over 2 equals. I'm subtracting the 3. What do I need to do now? Divide by 3. So what's -3 divided by 3? -1. Good. Okay, we've done this before. Okay. Tangent and cotangent, I know, are not our favorites. Okay, but we should have enough knowledge about this. We're looking for a place where your x-coordinate and your y-coordinate are the same, because tangent is what divided by what? Sine over cosine. All right. But we want them to be the same, but what do we want to know about their signs? They're one of them has to be negative, not both, right? Because both negative would mean I have to have a positive 1 here. So what do the coordinates look like when it's 1? Yeah, we're looking for this, right? But I want one of the 2 coordinates negative. It does not matter which one, okay? All right, so help me find this on here. Where's the first one that this happens at? 3 pi over 4, perfect. Over 4. It should be x. Yes, I don't know. What did I do? Oh my goodness. There were lots of 3s. Okay, x over 2. All right. And then what did we say the other one was? Also 7 pi over 4. Perfect. Okay. Interesting on this one, though. Okay, it's not a multiply, or it's not a multiply by the reciprocal thing this time. It's under division. How do I get that 2 to the other side? Yeah, I'm going to multiply, right? Okay, so when I do that multiplication, I get x here. 2 goes into 4 how many times? 2. So 3 pi over 2. And then here, 2 goes into 4 2 times again. So 7 pi over 2. Remember, the idea is that we would be canceling on the left side. I just ignore that part, right? Because I've done it in my head. All right. Any questions on tangent?
How come we got 3 pi over 2? How come we didn't use it at
How come it's not?
How come it's not like 6 pi
over 4?
Oh.
Because I reduced my fraction.
Okay.
Right? Okay. And it's not 3 pi over 8 because we had to multiply this time instead of divide. Okay. Any other questions? Okay. All right. I want everybody to take a minute, see how far you can get with 22 on your own. Go beginning to end. At the least, you should be able to isolate cotangent, right? Once you've done that, see if you can figure out what angle it goes to. Okay. Give you about 20 seconds on your own. Okay. So let's take a look at this. Okay. What? Apparently 3 was my favorite number when I was writing these notes, huh? All right. What do I need to do with this one, this 3 right here first? Subtract. Okay, so 3 cotangent of negative theta equals, what was 3 minus 3? 0. Okay. How do I move this 3 now? Divide. So cotangent of negative theta equals what's 0 divided by 3? 0. Okay, cotangent is what divided by what? Cosine over sine, meaning my cosine is 0. What's my sine have to be equal to? 1. And does it matter if it's positive or negative? No, so either one works. All right, so help me out with my radian measures. Where did you find this at? Okay, pi over 2 I like. Okay, where else? Also 3 pi over 2 is good. All right, and then what do I need to do with this negative that's in front? Divide, multiply. It really doesn't matter with a negative, right? So we're going to do theta equals negative pi over 2 and theta equals negative 3 pi over 2. Okay? Hopefully not too bad. It was one extra little step, right? Not a big deal. Okay? So here's what I have for you. Okay? I have an assignment. So you've got a good 20 minutes if you want to start working on this now. Okay? So we're going to, it's posted in Google Classroom. Okay, so if you go to Google Classroom, it's there. Remember, when I do the worksheet assignment, I do put the answers on the bottom just so that way you guys you can check your work. Okay, I think I left you enough room on the worksheet to be able to write. Let's see if it comes up. All right, so it should be this number 42. Okay, it's posted in there in Google Classroom somewhere under classwork. Okay, Google's just being super slow. Okay, it's right here. Okay, so that's what I have for you to work on the rest of the period. If you don't finish it today, don't stress about it tonight, especially if you've got an AP test tomorrow, right? Stress about the AP test. We're going to work on it again tomorrow in class a little bit. Okay. But remember, I won't be here to support tomorrow. That hopefully it'll be Mr. Clifton will be here to support tomorrow. Okay. All right. So you have the rest of the period to work on that. Okay. So get it out, get it done. Yeah.